Hi, my name is Mariven H. Banyas and I'll be teaching you today the antiderivatives or the indefinite integrals. So let's start with the definition. Definition of antiderivative. A function f is an antiderivative of f of an interval of 1 if f over 1 or exclamatory example of x is equal to f of x for all x in 1. So in representation of an antiderivatives, if f is an antiderivative of f of an interval of 1, then g is an antiderivative of f on the interval 1 if and only if g of the form of g of x is equal to f of x plus c, and for all x in 1 where c is constant or is a constant. So in the notation for antiderivatives, as you can see on the screen, when solving a differential equation of the form dy over dx is equal to f of x, and it is convenient to write it in a equivalent differential form if dy or dy is equal to f of x, open and close parentheses, dx, or the integral of dy is equal to integral of f of x dx. And lastly, the operation of finding of all solutions of this equation is called antidifferentiation for indefinite integration, and is denoted by an internal sign, integral sign. The general solution is denoted by, as you can see on the screen, variable of integration is dx, is what we call, and integrand is what we call the f of x. And the constant of integration is plus c. And the antiderivative of f of x is f of x. And second, we also have what we call a basic integration rules. First one is a zero integration. If the integral of 0 dx is equals to c, or 0 will always be equal to c. And that is the zero integration rule. In constant rule, integral of k dx is equal to kx plus c, or 2x plus c. And the constant multiple rule, integral kf of x dx is equal to k integral f of x dx plus c. And the sum of difference rule, integral of bracket of f of x, positive or negative, g of x bracket dx is equivalent to integral of f of x dx, negative or positive, integral g of x dx. And the power rule, which is integral of x over n to the power of n dx is equal to x to the power of n plus 1 over n plus 1 plus c, where n isn't equal to 1 power rule. And lastly, the trigonometric function. Integral of cosine x dx is equal to sine x plus c, which is sine x dx is equals to negative cosine x plus c. And second squared x dx is equal to tan x plus c. And second x tan x dx is equal to sec x plus c. And cosecant squared is equal to x dx is equal to negative cotangent x plus c. And cosecant x cotangent x dx is equivalent to, or is equal to, negative cosine x plus c. And if you're wondering, as you can see on the screen, basic integration rules is what we call the substitution of every constant or every trigonometric function. So I'll be giving 3 problems of antidifferentiation or the indefinite integral. So first is the integral of x for x dx. So the solution would be, you write it as 4 is the integral of x dx. So we bring out 4 to the integral of x dx, where we place 4 to the parenthesis of x 1 plus 1 over 1 plus 1 parenthesis plus c. So where did we get plus c? That is the substitute or the constant of c, or we replace it as plus c. And if you're wondering where did we get the x to the power of 1 plus 1, so in a mathematical rule, x is equal to 1 or 1 is equal to x, and the denominator, which is 1 plus 1, which is n plus 1, or what is n is the power of x or the equivalent of x, which is 1. So second, we inside the parentheses we add them all together, which is x squared over 2, and where we write it as 4 open and close parentheses x squared over 2 plus c. And next we add them, we multiply 4 to the x squared over 2, which is 4 over 2 x squared plus c. And as you can see in the picture, where in mathematical rule we can substitute 4 over 2, which is 2x squared plus c, and that is our final answer. And our second problem is the integral of 2 minus cosine x dx, or 2 negative cosine x dx. So the first step would be we place 2 outside the integral, which is 2 integral negative cosine x dx. So as you can see in the rules of trigonometric function, what is the substitute or the equivalent of negative cosine, which is sine, or which is sine x. And we place 2 outside the integral and substitute the integral to parentheses and place sine x inside it, is where we substitute negative cosine to sine x, and we place plus c. And lastly, we multiply 2 to sine x plus 2 sine x, which is the equivalent of 2 sine x plus c. And that is the example of the basic integration rules, or the trigonometric function example. And our last problem is the integral of 3x dx, where we solve it as the same as the first problem that I've given, which is the integral of 4x dx. So how do we solve the 3x dx, or the integral of 3x dx? First, we place the 3 outside the integral and place x dx, where we substitute the integral which is the open and close parentheses, and where we place dx is equal to c, or plus c. And second, we place 3 open and close parentheses, which is x to the power of 1 plus 1 over 1 plus 1 parentheses plus c, where we add them all together is equivalent to 3 open and close parentheses x squared over 2 plus c. So where we multiply 3 to the open and close parentheses, which is x squared plus 2 x squared 2 over 2 plus c, and our final answer would be, where we multiply it, and our final answer would be 3 over 2 x squared plus c. So that is it for our lesson, the antidifferentiation or the indefinite integral. And my name is Mariven H. Banyas, and thank you for listening.